Good morning, learners and viewers. Welcome to the session of Quantitative Analysis for Managerial Application, MFPC 005. I am your academic counselor, Ashlesh Saxena. Till now, we have completed block 1, 2, 3, and we are undergoing through block 4. We will continue with correlation, that is your unit 14, and regression, time series analysis. And after completing this, we will be discussing on some numericals basically which are important for the subject. As far as degree and types of correlation are concerned, we can see that what is the degree, because this degree is used in interpretation of the result. From the values of R, what we get from calculation, we decide what is the degree of the observation. Absence of correlations means R is zero. If perfect 1 plus 1 or minus 1 is there, that is perfect correlation. Either if it is plus 1, it is positive correlation, and if it is negative 1, it is negative correlation. High degree value is if the value is between 0.75 to 1, and similarly for negative 1. For moderate, 0.25 to 0.75, and for low degree of correlation, it is from 0 to 0.25. R is a dimensionless quantity, that it does not depend on the units employed. What are the properties of correlation coefficient? Correlation coefficient R lies between -1 to +1. The correlation coefficient R is a pure number and is independent of the unit of measurements of the variables. The correlation coefficient R is independent of change of the origin. That is, the value of R is not affected even if each of the individual value of the two variables is increased or decreased by some non-zero constant. The correlation coefficient R is independent of the change of scale. That is, the value of R is not affected even if each of the individual values of the two variables is multiplied or divided by some non-zero constant. What are the different methods for determining correlation? We will be discussing the most commonly used methods, that is scatter plot, Karl-Pearson coefficient of correlation, and Spearman's rank correlation coefficient. We start with scatter plot. Scatter plot, also called scatter diagram, are used to graphically investigate the possible relationship between the two variables without calculating any numerical value. In this method, the value of the two variables are plotted on a graph paper. You can see it after plotting the observations on the graph. If that is a straight line, that is perfect R, that is perfect positive correlation. And if the points are scattered and they are moving up, and the distance between them, the width between them is less, then there is high degree of positive correlation. If they are scattered and they are moving up, that is low degree of positive correlation. And similarly, if the graph is coming down, it is for negative correlation. And if all the points are scattered, that is R is equal to 0 and there is no correlation between the two variables. Secondly, it is Karl-Pearson coefficient of correlation. It gives the precise numerical expression for the measure of correlation. It is denoted by small r, and the value of R gives the magnitude of correlation, and its sign denotes its direction. Plus sign up, negative coming down. And mathematically, it is calculated as R equal to sigma xy upon n into sigma x sigma y, where x is equal to x minus x bar, y is equal to y minus y bar, sigma x is as standard deviation of x, and sigma y is standard deviation of y, where capital N is the number of pair of observations. Now, the formula is for calculating sigma x and sigma y. At the end, we can say that if we have calculated all the values, then R is equal to sigma xy upon under root of summation x square into under root of summation y square. Actually, how these values are calculated. So mathematically, we can see that we have the observations with us. They are converted by using these three formulas. If we are using actual mean, it is the first one, and if we are using the assumed mean method, then the formula changes. The context remains the same. And if we are having if we want to use direct method, then we simply apply the standard formula, which is over here. Now, if in the problem covariance is given or we have to use the information, if the information is in the terms of covariance, then we have to use this one. Now, the third method is Spearman's rank correlation coefficient. This method is based on the ranks of the items rather than on their actual values. That means we will be providing us the ranks to the observation. The advantage of this method over the other is that it can be used even when the actual values of the items are unknown. For example, if you want to know the correlation between honesty and wisdom of boys of your class, you can use this method by giving ranks to the boys. It can also be used to find the degree of agreement between the judgments of two examiners or two judges. We apply this formula R equal to 1 minus 6 sigma t square upon n into n square minus 1. We will be going through a problem and we will see how this formula is applied. If the value of R, capital R, is plus 1, it is a perfect correlation, we are aware of it. And R if is equal to minus 1, it is a perfect negative correlation, that is or complete agreement. In the opposite direction, if R is equal to 0, no correlation. How this formula or the ranks are defined or calculated? Give ranks to the value of the items. Generally, the item with the highest value is ranked 1, and then the others are given rank 2, 3, 4, 5, 6, according to their value in the decreasing order. Then we have to calculate the difference. T is equal to R1 minus 2R because we will be comparing two observations. We have to see that summation T is 0 and it will always be 0. Then we have to calculate T square and then summation T square and we apply the formula. That is R equal to 1 minus 6 sigma T square upon n into n square minus 1. Now we will go through a problem. From following information with the correlation coefficient, the advertisement expenses and sales volume using Carl Pearson's coefficient of correlation method. That means we will be finding out the relation between advertisement expenses and sales volume. This data is given to us. We will be converting this data into the tabular form. Now, 1, 2, 3, 4 till 10. That means there are 10 observations. N will be 10. X and Y. We will be calculating X, summing it, Y, X minus X bar, X square, Y minus Y bar is calculated, Y square and the product of XY. Then we find out the mean. X bar is equal to summation X upon N, that is 140 divided by 40. That means your X bar will be 40. Y bar is equal to summation Y upon N, which is 580 divided by 10, that comes out to 50. After calculating all these values, we have to calculate summation X, summation Y, summation X square, summation Y square, and summation XY. We will be applying this formula because the observations are in this form. We calculate R equal to summation XY upon summation X square into summation Y square. Values are substituted and we get a value of plus 0.866. How the result is interpreted? From the above calculation, it is very clear that there is a high degree of positive correlation because the value is more than 0.75 between the two variables, that is increase in advertisement expenses leads to increased sales volume. We move on to regression, that is unit 50. Regression analysis is a statistical method that helps us to analyze and understand the relationship between two or more variables of interest. The process that is adapted to perform regression analysis helps to understand which factors are important, which factors can be ignored, and how they are influencing each other. We can say that Age and height can be described using a linear regression model. Since a person's height increases as his age increases, they have a linear relationship. Regression models are commonly used as a statistical proof of claims regarding everyday effects. A researcher might administer various doses of a certain drug to patients and observe how their blood pressure responds. This can be broadly classified into two major types. One is linear regression, and the second one is logistic regression. What is the difference between correlation and regression? We have heard things, that is correlation and regression. Now we will see what is the difference between these two. As far as correlation is concerned, it measures the degree and direction of relationship between the variables. It is a relative measure showing the association between the variables. Correlation coefficient is independent of change of both origin and scale. Correlation coefficient is independent of the unit of measurements. Expression of the relationship between the variables ranges from -1 to +1, and it is not a forecasting device. As far as, on the other hand, regression is concerned, it measures the nature and extent of the average relationship between two or more variables in terms of the original units of the data. It has an absolute measure of relationship. Regression coefficient is independent of change of origin but not of scale. Regression coefficient is not independent of units of measurement. And the expression for relationship between the two variables are given by or can be given by a relation. It can be a linear one, as you can see, y is equal to a plus bx. It can be a quadratic one, as y is equal to a plus bx plus cx, depending upon the situation. It is a forecasting device which can be used to predict the value of dependent variables from the given value of independent variables. How regression line and regression equations are formed and what are the different parameters what we have to consider. Regression line and regression equations are used synonyms. Regression equations are algebraic expressions of regression lines. Let us consider two variables x and y. If y depends on x, then the result comes in the form of a simple regression. If we take the case of two variables, x and y, we shall have two regression lines, as the regression line of x on y and regression line of y on x. The regression line of y on x gives the most probable value of y for given value of x, and the regression line of x on y gives the most probable value of x for the given value of y. That is why we have two regression lines. However, when there is either perfect positive or perfect negative correlation between the two variables, the two regression lines will coincide. That is, we will have one line. If the variables probable are independent for the given value of y, and that is why we have two right angles. That is, however, when there is either perfect positive or perfect negative correlation between the two variables, the two regression lines will coincide. Of y, that is, we will have this line gives the variables probable are independent for the given value of y, and that is why we have two right angles. That is, however, when there is either perfect positive or perfect negative correlation between the two variables, the two regression lines will coincide. Of y, that is, we will have this line gives the variables probable are independent for the given value of y, and that is why we have two right angles. That is, however, when there is either perfect positive or perfect negative into x minus between the variables, the two regression lines will coincide. Y minus y, that is, we will have this line as x is equal to a plus b1. In the above two regression lines or regression equations, there are two regression parameters, which are a and b, where a is the unknown constant and b which is also denoted by Byx or Bxy, is also another unknown constant, popularly which is known as regression coefficient. Hence, these A and B are two unknown constants, fixed numerical values, which determine the position of the line completely. The parameter A determines the level of the fitted line, that is, the distance of the line directly above or below origin. The parameter B determines the slope of the line, that is, the change in y for unit change of in x. If the values of constant A and B are obtained, the line is completely determined. But the equation is how to obtain these values. The answer is provided by the methods of least square. We can see if we are asked to calculate x and y, we find out summation x is equal to na plus b summation y, and summation xy equal to a summation y plus by square. Similarly, for y on x. This above method is popularly known as direct method, which becomes quite cumbersome when the values of x and y are large. This work can be shifted, simplified, if instead of dealing with actual values of x and y, we take the deviations of x and y series from their respective means. That means we will be changing y to y minus y bar. Going back, we can see that for the equation of y on x, if y is equal to a plus bx, then the change will be y minus y bar is equal to byx into x minus x bar. And similarly, it is done for x on y. In this new form of regression equation, we need to compute only one parameter, that is b. And b, which is denoted either by byx or bxy, is called regression coefficient. Regression coefficient, the quantity b in the regression equation, is called as the regression coefficient or slope coefficient. Since there are two regression equations, therefore we have two regression coefficients. Regression coefficient x on y, symbolically it is written as bxy, and for regression coefficient y on x, it is written as byx. Now, depending upon the conditions or the information provided in the problem, we can calculate regression coefficients of x on y and regression coefficients of y on x, depending upon the conditions given in the problem. If we are using correlation coefficient r and standard deviation sigma, then bxy is equal to r into sigma x upon sigma y. And if we are using the direct method, no, it can be easily calculated. Summation bxy equal to n summation xy minus summation x summation y upon n summation y square minus summation y whole square. When the deviations are taken from the arithmetic mean, then we have to calculate small x, and then small x is x minus x bar, and small y is y minus y bar. And similarly, same thing are being transformed for y on x. The coefficient correlation is the geometric mean of the two regression coefficients. That is, r equal to under root product of bxy into byx. If one of the regression coefficient is greater than unity, the other must be less than unity, since the value of correlation coefficient of correlation cannot exceed unity. But these are the basic properties of the regression coefficients. Both the regression coefficients will have the same sign. If bxy is negative, byx will also be negative or positive. In other words, it is not possible that one of the regression coefficient is having minus sign and the other one is having plus sign. The coefficient of correlation will have the same signs as that of regression coefficient. If byx and bxy are plus, then r will be having plus sign. And if regression coefficients have negative sign, the r will also have the negative sign. Now, we can discuss this problem, how regression coefficients, regression lines are calculated or drawn. After investigation, it was found that the demand for automobiles in a city depends mainly, if not entirely, upon the number of families residing in that city. Below are given the figures of the sales of automobiles in the five cities of the year 2019 and the number of families residing in those cities. We have taken these five cities: Bilagi, Bangalore, Hubli, Kalaburagi, and Mangalore. And number of families values are given, and number of sales of automobile in thousands is denoted by Y. This data is given to us. Now we are to fit a linear regression line Y on X by the least square method and estimate the sales of the year 2020 for the city Belagavi, which is estimated to have 100 lakh families, assuming the same relation holds true. The problem will be converted into this form. In front of the respective cities, x and values of x and y will be written. And then we will be calculating x square and the product of xy. We will be summing it. Now, how to draw the regression equation line of y on x, that is y is equal to a plus bx. Now, we use two normal equations. Summation y is equal to n a plus b summation x. Summation xy is equal to a summation x plus b summation x square. So we will, because we have to calculate the value of a and b, that means we should have minimum of two equations with us. We, after placing up the form values from the problem, what we have calculated, we will calculate the value of a and b. And a will be 4.885 and b will be 0.443. Putting up the values in the basic equation, that is the regression equation of y on x, that is y is equal to a plus bx. That comes out to be y equal to minus 4.885 plus 0.443 into x. Now, we were asked to calculate the estimated sales of automobile Y in city Belagavi for the year 2020, where the number of families, that is X, are in 100 in lakhs. Placing of the values of X, that is 100, in the equation, we get a value of Y equal to 39.415, which means the estimated automobiles for the city in 2020 will be 39.415. Now we move on to time series analysis. Time series is a sequence of data points measured typically at the successive time spaced at uniform time intervals. The time interval may be an hour, a day, week, month, or year, depending upon the purpose of data collection. Most commonly, a time series is a sequence taken at successive, equally spaced point of time. Thus, it is a sequence of discrete time data. Examples: time series is used in pattern recognition, signal processing, weather forecasting, and earthquake prediction. Time series analysis comprises method for analyzing time series data in order to extract meaningful statistics and other characteristics of the data. It is used to detect pattern of change in statistical information over regular interval of time. These patterns help us in arriving at an estimate for the future so as to cope up with the uncertainty about the future. Time series forecasting is the use of a model to forecast future events based on known past events, that is to be predict data points before they are made. An example of time series forecasting is econometrics in predicting the opening price of a stock based on its past performance. Forecasting is an essential tool in the strategic planning and decision making process of an organization. The applications of time series, there are various applications of time series. It can be economic forecasting, sales forecasting, budgetary analysis, stock market analysis, yields projections, process and quality control, inventory studies, workload productions, utilities studies, and essential studies, and many more. The usage of time series model is twofold. First is to obtain an understanding of the underlying forces and structure that produce the observed pattern. And second is to fit a model and proceed to forecasting monitoring or even feedback and feed forward control. But these are the applications. Now, what is meant by variations in time series? There are four types of change or variations involved in time series analysis. These changes are known as components of the time series. They are secular trend or long-term trend, cyclic fluctuations, seasonal variations, and irregular variations. Secular trend or long-term trend is the value of variable tends to increase or decrease over a long period of time. The variable may be population, sales, cost of living, death rates, and so on. The trend includes steady movements over a fairly long time and does not include short time oscillations. The trend may be in the form of a slow, fast increase, decrease. These changes occur as a result of general tendency of the data to increase or decrease as a result of some identifiable influences. The trend is most commonly seen in data related to economics, business, and population. As far as cyclic fluctuations are concerned, this refers to regular swings or patterns that repeat over a long period of time. Cycles are the upward and downward movement about the trend line over a period of time. The movements are considered cyclic if the fluctuation occurs after the time interval of more than 1 year, and it can be as long as 15 to 20 years. In general, these cycles are not regular. They may have different periods and intensity, that is the amplitude. The most common example of cyclic fluctuation is business cycle. The cycles after the time affected more than 1 year, and it can be and render as long as 15, which cannot be separated. In general, major that these cycles are not regular. They may have different periods and seasonal variations. And seasonal variation is the name. The most common example of cyclic fluctuation pattern of is business cycle. Within a year, the cycle occurs to after the time affected more than 1 year. Then it can be and render as long as 15, which cannot be as many variations are regular pattern. They can be predicted fairly. They may have different periods. Some factors that cause seasonal variations, seasonal and climate changes affects the sales of many products. For example, sales of coolers and ACs is always more during summer months. Customs and festivals. Tradition and customs also affect the pattern of sales. For example, sales of paints and furnishing goods is more during Diwali. Sales of sweets is more during festivals, etc. Irregular variations, the fourth one. Irregular variations are rapid, unpredictable, and random changes in the data. The changes are caused by short term, unanticipated, and non recurring factors, incidents like wars, strikes, floods, famine, earthquakes, etc. The effect of Iraq war and terrorist attack on crude oil prices is the example of irregular variations. Then comes decomposition of time series. Analysis of time series consists of identification of various factors which cause the variation in the time series, and separating, analyzing, and measuring the effect of these factors independently. The objective of decomposition of time series is to break time series into four components, that is trend, cyclic, seasonal, irregular. Trend is denoted by T, cyclic by C, seasonal by S, and irregular by I. So as to isolate influence of each of the four components of the actual series. The two common models used for decomposition of a time series are multiplicative model and additive model. Multiplicative model, according to multiplicative model, the values of time series y can be found by multiplying the four components, that is t into c into s into I. The effect of four components on the time series is interdependent. It is appropriate in situations where the effect of four components is measured in relative terms rather than the absolute values. Additive model. This model is based on the assumptions that the effect of four components can be estimated by adding the various components of the time series. That is y equal to t plus c plus s plus I. This model is less common. It is appropriate in situations when variation in the time series are in absolute values and can be separated to each of the four parts. Hence, each part is independent. Each part can be negative or positive. Now, measurement of secular trend. Secular trend measures the long-term direction of series. The study of secular trend helps in identification of a historical pattern, projecting past patterns into future, estimating the trend components from the series. The most common method for measuring secular trends are freehand curve method, semi-averages method, moving averages method, and method of least square. Freehand curve method is the simplest method. It consists of plotting the time series values on a graph paper and then drawing a freehand smooth curve through these points so as to reflect the long-term tendency of the data. This method is based on inspection, hence is subjective in nature. That is, only a specialist with long experience who knows the behavior of the variables can draw a line by mere inspection. Semi-averages method. In semi-averages method, the data is divided into two equal parts and arithmetic mean is calculated of each of the parts. These are called semi-averages. These 2 points are plotted corresponding to the midpoint of the respective class intervals covered by each part. The line joining these 2 points gives the straight line trend. This line can be extended upwards or downwards to get an estimate of future and past values. What are the advantages? It is not based on personal judgment, hence, the same trend line will be obtained every time. It is easy to understand. Trend lines can be extended upward or downwards to estimate the future or past values. Disadvantages, it is based on assumption of linear trend and use of arithmetic mean. Arithmetic mean has its own limitation as it may not be appropriate method in some cases. Moving average method. This moving average method is based on the concept that if the observations of a point in time are averaged out with the values immediately before and after it, it will smooth out the irregular components of the time series. This is very common method to determine secular trend. This method is subjective as it depends on the selection of the length of period for calculating the moving averages. For example, 3 years moving average or 4 years moving average, and so on. So as to remove the effect of cyclic variations. What is the method of least square? This is the method in which as trend line is determined using a mathematical equation of either a straight line or a parabolic curve. As this method is based on mathematical equation, it is not subjective and hence is more accurate. The equation used for fitting a straight line is yc is equal to a plus bx, where yc is the predicted value of dependent variable. X is the independent variable, which in this case is time. Further, A is intercept and B is slope. Both A and B are constants. The trend line has the following properties. The summation of all vertical deviation from it is zero. That is y minus summation of y minus yc is equal to zero. And sum of the vertical deviation squared is minimum. That is summation y minus yc squared is the least. Now, how to fit a straight line? By the equation used for fitting a straight line is yc is equal to a plus bx, where yc is the predictive value of the dependent variable, x is the independent variable, that is the time, a is the intercept, and b is the slope. Both a and b are constants. Now, how to determine, how to solve the problem? From the information given in the problem, we have to use, because as we are supposed to calculate the value of a and b, so we will be using two normal equations, that is summation y equal to na plus summation na plus b summation x and summation xy equal to a summation x plus b times summation x squared. The independent variable x is given order 1, 2, 3, 4, 5 for calculating summation x. Then comes auto-regressive integrated moving average, that is ARIMA. This model predicts future values based on past values. ARIMA makes use of lagged moving averages to smooth time series data. They are widely used in technical analysis to forecast future security prices. With this, we have completed our blocks. And now, moving further, I will be moving specifically on the numericals, which is the most important part of the subject. And the topics which are important as far as your numerical portions is concerned, it is related to measures of central tendency, measure of variation and skewness, continuous probability distributions, sampling distributions, testing of hypotheses, correlation, regression, and chi-square test. During my conversation, the lectures previously had, I had discussed some of the numericals simultaneously while I was discussing with the theory work. But here now, I'm specifically concentrating on the numericals. Now, we move on to how to calculate the measures of central tendency. How to draw a frequency polygon when the problem is given in this form. We are given price less than, which is in rupees, and number of the shares. Because for drawing up a histogram, we have to get the price into an ordered form. We will be converting this data because the data which is given to us is in the form of cumulative form. How to convert this data in the form of frequency distribution, that is the first important part. We will be deciding on the class intervals. As it was discussed, either it can be in a multiple of 5 or 10 or 100. So here the number is large. So we will be drawing it from 500 to 600, 600 to 700, and from till 900 to 1000. You can see that price part is completed. Now we want to convert into the frequency distribution. So we can see from the problem that from 500 to 600, there are only 25 items. So that means in front of below 500 to 600, we will be writing 25. And we can see from 500 to 700, there are 55 items. That means 25 is included in it. So we will be subtracting 25 from 55, we will get 30. And similarly, moving on till and 100 to 1000, we will see that for that price range, 15 shirts are there. Now, we will be converting this into the graphical form. We will be drawing the histogram. Histogram is drawn. So, first of all, on x-axis, we will be taking up the prices, and on the y-axis, we will be taking up the number of shirts. Using an appropriate scale, we will be drawing histograms. Histograms are closed rectangular figures, and their width will be, in this case, will be 100. And if we were supposed to, we have drawn histograms, but the question was related to frequency polygon. That means we will be joining the center value of these old histograms at the top, and we will get a curve which is shown in the solution. Now we move on to calculate the mean. The data is given to us, and we are supposed to find the mean of this group data. So what is the procedure? Two columns were given to us. As the frequency numbers are less, so we will be using the direct method. That means we will be simply calculating the mid values, and we will be multiplying f with x. The frequencies are single digit numbers. In this case only, we can use this direct method. That is multiplying mid values with the frequencies and summing it up. That summation of x comes out to be 4235. Summation f is 25. Our mean is summation of fx upon summation f. We get 169.4. Now, we have to calculate monthly mean salary. Now you can see over here that the frequency numbers are big enough. Then we will be changing pattern of solving the problem. Here what we will be doing, two columns were given to us, that means monthly sales and number of firms were given to us. What are the different steps we have to follow? First of all, we have to calculate the value of mid value. Mid value is calculated at sum of 0 plus 150 divided by 2. That comes out to be 75. As you can see, we don't have to calculate every time all these values. We can see that the difference is 150. So what we will be doing? In 75, we will be straight away adding 150 till the last one, till 825. Then we have to calculate D. D is x minus a upon I. Here we can see that there are 6 observations. So at the center value, here in this case we take as 375. So A will be 375. X minus 375 divided by I, that is 150. The row where we have S, straight away we will be writing 0. And above it we will be writing -1, -2. And below 0 we will be writing +1, +2, +3. Then we will be calculating F into D. We get all the 6 values, we will be summing it up. We get summation of D equal to 1. Your summation F is 135. Now, what is the formula? If we go back to the theory, x bar is equal to A plus summation FD upon summation F into I. A is 375, summation FD is 1, I is 150, and summation F is 135. Calculating, we get 376.11. That is the monthly sales. Now, we have to calculate the median of the following group data. For median, we have to calculate cumulative frequency. Now the question is how cumulative frequency is calculated. The column consisting the number starts with 1. In front of 1, we will be writing 1. For finding the preceding cumulative frequency, we will be adding the number. We will be adding 1 plus 4, we get 5. 5 plus 8, we get 30. 30 plus 7, we get 20. 20 plus 5, 20. When we will be summing up the frequency, we will get the same number. Summation f is equal to 25 as the last value of the cumulative frequency. I would like to tell one thing. If there is some error, these two numbers will never be same, so that you can fill check where the error is. Now, we have to calculate median. So for that, we have to use n by 2. N by 2 means 25 by 2, which comes out to be 12.5. Then we have to see in which class this cumulative frequency 12.5 comes. This refers, which is depicted by black arrow at 13. That means your median class will be 162.70. We will be using the formula for median, that is L plus n by 2 minus CF upon FM into I. Your L is the lower value of the median class, that is 160. N by 2 is 12.5. Your cumulative frequency above the median class is 5. Your frequency of the median class is 8, and the difference is 10. With that, we will be getting the value after calculation. We get the value 169.375. Next, we move on to the same problem. We move on to how to calculate mode. For mode, we have to use this formula. That is MO equal to LMO plus FM minus 1 into I upon twice of FM minus FM minus 1 minus FM plus 1. I will show you how all these FMs and LMOs calculate. First of all, we have to decide in which class interval we are getting the maximum frequency. From the particular problem, we can see that it is in the third row, that is A. Above that, it will be FM minus 1, and below 8, it will be FM plus 1. And the modal class, that is the frequency class with the highest value, will be LMO, will be 160. Putting up all the values, we will get mode as 168. Now we have to calculate the mode by using the empirical relation between mean, mode, and median. Mean and median are given to us, and we have to calculate the mode. The empirical relation between these three are mean minus mode is equal to the difference of 3 times the difference of mean minus and median. So we can convert it into mode is equal to 3 median minus 2 mean. Putting up the values, we will get 5614.88 as the mode for the present problem. Now we have to construct a pie chart. The data is given to us. There are 6 reasons, and simultaneously there are 6 respondents. We have to convert this into a pie chart. Pie chart is a circular graph, we can say. So how that is drawn and what are to be calculated. What are the values? That means in a circular that consists of 360 degrees. So we will be converting that into degrees. For that, we have to sum up the total of the number of respondents. In this case, it comes out to be 1000. Then, for the respective class, we have to calculate the percentage of the respondent. And mathematically, it has been calculated that 1% is equal to 3.6 degrees. So straight away, we can multiply 28 by 3.6. We will get all these values. And to check whether your calculation is correct, you can sum it up. When you will be summing it up, that will be 360 degrees. How to draw it? We are having 6 observations, so we will be using 6 different colors to notify them. And the degrees are given to us in the last column. So we will start from any position, and with the help of your D, you can draw all the angles and color them accordingly what has been assumed to depict the relation. So this is how a pie chart is formed. Now, how to calculate quartile deviation and its coefficient. The data is given to us. You have to calculate the quartile deviation and its coefficient. Is this an appropriate measure for the study of measurement of variability? Comment on it. Okay. So what we will be doing? We will be doing cumulative frequency. As discussed, cumulative frequency can be calculated 4 in front of 4. 4 plus 11 is 15. 15 plus 8 is 23. 23 plus 10 is 33. Until on, we move on to 60. If we will be summing up number of companies, it will be 60. Here that means here n is 60. So first of all, we have to calculate Q1. Q1 is n by 4. That means the 15th value. We have to see in which the 15th item comes. That comes in 40 to 45 group. Then we move on to Q3, that is 3 times of this. That will be straight away 45. 45 comes in 55 to 60. We have to calculate the value of Q1. Q1 is L plus N by 4 minus CF upon F into Y. And Q3 is L plus 3N minus 4 minus CF upon F into Y. Putting up all the values of N by 4, 3N by 4 and the respective frequencies in the formula of Q1 and Q3, you will get two values of Q1, you will get the values of Q1 and Q3. Here Q1 is 45, Q3 is 60. Quartile deviation is Q3 minus Q1 by 2. We get quartile deviation is 7.5. And we have to calculate the coefficient of quartile deviation. That is Q3 minus Q1 upon Q3 plus Q4. That comes out to be 0.1428. Now, we will calculate Bowley's coefficient of skewness and Carl Pearson coefficient of skewness. This is in a particular problem. We will be showing you all the calculations. The data has been converted into this tabular form. Monthly wages and number of employees, that is the frequency were given to us. We have to calculate all these columns for the different values because we will be calculating standard deviation, mean, quartile, median. So I'm showing all these calculations in a particular problem. First of all, we will be drawing the middle values that is x. Then we will be calculating d, that is x minus a upon I. Then d square, fd square, fd, and the last one is the CF. For calculating mean, we have to use the formula a plus summation fd square by n into I because frequency is too large. The mean after calculations come out to be 766.68. Then we will be calculating standard deviation. That is under root summation fd square upon n minus summation fd upon n whole square into I. Remember, I is apart from under root. So after the calculation, we get standard deviation as 124.8. And the formula for median is L plus N by 2 minus CF into I by F. Putting all these values, we get median as 755.66. We have to calculate more. Here, for calculation purpose, I am showing up more by this formula, or we can use straight away the empirical relation. We'll get the same result. Now, quartile 1 is Q1. Formula is known to us. Quartile Q1 will be 680, Q3 will be 850. Now, what is the formula for Bowley's coefficient of skewness? That is denoted by SKP equal to mean minus mode by SD. It comes out to be 0.18. And when we calculate Carl Pearson coefficient of skewness, the formula is Q3 plus Q1 minus 2 median upon Q3 minus Q1. We get a value of 0.18. We can see that by the same, for a particular problem, we are applying two coefficients of skewness and we are getting almost the same relation. Now, for probability. Probability is something we have to really work on it. I will try to make you understand how the problems related to probability are understood or it can be solved. A problem in statistics is given to three students, A, B, and C, whose chances of solving is independently are 1 by 2, 1 by 3, and 1 by 4 respectively. We have to find the probability that the problem is solved. At least two of them are able to solve the problem. And exactly two of them are able to solve the problem. The question seems that it's easy, but technically, when we are coming into the probability part, it's not that easy, but even it's not that difficult also. So we have to see, we have to convert these values into mathematical relation. So we have to calculate that the first of all the problem is solved. What we will do? We will be subtracting the probability of not being solved by anyone. If the problem is not being solved by anyone, if PA is 1 by 2, so PA bar will be 1 by 2. If PB is 1 by 3, then PB bar will be 2 by 3. And if PC is 1 by 4, PC bar will be 3 by 4. If the problem is solved means the problem has been solved at least by one of them out of the three. That will be 1 minus probability, the product of P A naught, B naught, C naught. We will get 3 by 4. Secondly, at least one of them is able to solve the problem is that. But the problem is solved by at least two of them. In that case, either first or second plus second or third plus first or third minus 2 times of PA, PB, PC. But this is the basic relation of set. We are applying the set theorem for solving probability problem. The third one is the problem is exactly solved. Exactly two of them are able to solve the problem. In that case, see the difference. PA into PB plus PB into PC plus PA into PC minus 3 times of PA, PB, PC. We get the value as 1 by 4. Now, second problem is the probability that a student A solves a mathematical problem is 2 by 5, and the probability that a student B solves is 2 by 3. What is the probability that the problem is not solved? The problem is solved, both A and B working independently, each other solves the problem. These are the interpretations for how the problems can be solved. With this, we will be concluding our discussion on quantitative analysis of for managerial application. And I hope you might have understood the subject correctly, properly, and I thank you all for sparing time and listening to me, and I pray God to get you success in all of your future aspects.